Thank you very much, all of you. Don't go out, we're not there for a break yet. So just a quick clarification. So when we talk about the ETSI standard, the code of practice is also an ETSI standard. Again, I'm promoting it, so we will check. However, next panel, Helen and Tim. The next panel is about red teaming. So we talked about governance, we talked about research horizons. Let's talk about real stuff. Testing in real enterprises.
Hi, everybody.
Hi.
Hi, it's really great meeting you, and now it's very great meeting you in person, first time. Super excited about this event. Great job, everybody here. So today, we're going to talk about red teaming and actually some of the practical applications around that. So, but first, before we go into that, just for fun, I know we can explain in technical format what we do for work, but starting with each of you, starting with Dan, then Matt, then Rachel, explain briefly, how do you explain your work to some relative who is not in tech, yeah? And why this panel and why today?
Okay, so can you hear me?
No.
Oh, there we go. Yeah, so I'm a researcher in Microsoft's AI Red Team, and what I do is take AI deployments, and of course,
I'm not technical.
not technical.
To
Okay, what I do is I take. Do you know ChatGPT, Grandma? I know you use it. I make sure that it can do bad things like swear at you, and that's what I do on a daily basis. So yeah, why here today? I mean, I'm really excited because, well, I think that the innovation is moving very, very fast, right? And it's moving faster than we can protect it. And I think no single institution is going to provide a solution for everybody. And initiatives like OWASP and MITRE and other programs that we're advising, are going to help us come together and communicate with a common language. So this is why I'm very excited today now.
Amazing. Yeah, I guess my answer is going to be even less technical. And for those of you that have kids, like everyone's kind of said before, AI is very similar to a baby or a child, a very small child. It's like early in maturity. And when your child becomes a toddler, they actually start to have more agency. They can walk around, they can put things in sockets, they can walk down and upstairs. My son actually thinks it's really exciting to try and ride a suitcase like a sled down the stairs. So my aim is to try and stop all of these risky behaviors and make sure that we can foresee the things that might happen. But instead of toddlers and children, it's actually for AI systems and the systems that are kind of changing people's lives. Why now? Well, one of my colleagues said earlier, the kind of 0 to 8 month period is the sweet spot where they can't really do very much. And at 8 months, they start standing up. And I think agents are the kind of times that these systems are standing up.
So my analogy will be even less technical and will sound horrible after yours, comparing these to children, because I usually say I get paid to break things. That's like my simplest explanation. But if there's a slight more technical layer, I will often tell people I socially engineer computers, right? And I actually think that's why now for me, like I've been in red teaming for a while, but I'm just really fascinated that as human beings, especially when we talk about generative AI, when we talk about LLMs, we have created socially engineerable computers. And now we're like sticking them with autonomy in charge of like very sensitive operations in our business, which is a fascinating role as somebody who has done social engineering engagements and done pen testing before.
Fantastic. Very great to meet you. Awesome analogies. So maybe this one will start with Dan, and then we can add up with Rachel and Matt. So without naming names, what would be the AI failure or a weird thing behavior that you see? And it's like, yeah, you would think this is really where we gotta find a better ways of red teaming the systems.
So I think that, yeah, I think we did a lot of work recently. I've been focusing a lot on compute use agents. And if you don't know what those are, they're agents with tools attached to them that can call actions like clicking a mouse on a VM or browsing a browser, typing, copying and pasting, these kinds of things. And we found a whole range of surprising things from that. And I think one of the biggest things for me that was a surprise is that you're basically, when you expose a browser and screenshots of a VM to the model, the agent as context, you're exposing any website on the web as an attack vector. And so this is something that, is essentially any website that's malicious, that can be hiding in the corner of the web somewhere, you can actually point to it from a very common website, right, like GitHub or something like that, by just decorating it in something that looks very benign. And so that was a massive jump for me. It's not indirect prompt injection anymore. It's like the whole web can be your attack vector. And I think that was quite shocking. And it leads to difficult ways to test, right? It's hard to test that. There are some existing frameworks, like I think there's one called OWASP, actually, since we're at OWASP today. But there are others, and they're very good at testing the browser-based agents. But I think in general, I'm working on it, and I know other teams are. And sort of when you have a VM, there are multiple applications. How do you really define what you trust, what you don't trust? What context are you feeding into the model? And I think this is very difficult to get right in kind of generic sense.
Rachel? So if my face looks like vaguely familiar to anyone, it's because I work a lot on the prompt injection entry of the old Gen AI top 10. And so prompt injection is always like very fascinating to me. And some of we alluded a little bit of sort of like waiting to do the top 10 for agentic because it wasn't quite ready, right? We kind of wanted to let it bake. But we did do some updates, and one of the updates that we did to prompt injection was to further explain that scope. That prompt injection is when user prompt data enters into the system where Gen AI exists, and it can actually influence not just the system prompt behavior or the attention level, but it can also influence like downstream goal setting and things like that. And so we expanded that in our last update of the prompt injection piece. And I think that's probably been the most fascinating part to me is as somebody who has done web application vulnerability testing before, right? We would have this list of SQL injections, right, that we could run through. But Gen AI being a non-deterministic system, it's a and the context windows and right prompt chaining and the way those attacks can be so different than just unsanitized user input has been really fascinating. And as I've done more of this hands-on, being able to the best way I can describe it is it's gives me the joy of lock picking again. Like you have a feel when you interact with these models that you develop over time, this like feedback feel when you can tell you're nudging towards a guardrail that's about to be jumped, right? And there's this feedback that you get that is very satisfying, but also makes it very hard to scale testing. Makes it really challenging in terms of red teaming. But it's like somewhere between social engineering and lock picking when you're doing these types of more elaborate prompt injection attacks.
I think I'll just add very quickly that it's not just like small scale or online environments that these agents act in, they also act in physical environments as well, which can be extremely risky. And it means that somebody who has access to your system, if you haven't kind of configured it correctly or applied the right security controls, can actually start to change things in the physical space, can change things around you, could unlock or lock doors. And I think that's quite scary. But it also might be worth noting that, your systems aren't only vulnerable to attackers. You can build a system that you might not have configured correctly that actually benignly acts in a way that you didn't expect. Like I know you're not allowed to name names, but I'll name myself. I've built systems before where I haven't configured like the max token length, and I've received an empty response from something, and then my model has gone and blitzed through like hundreds of thousands of empty tokens, and then just replied the end at the end of that, which is like comical and also quite upsetting.
We'll stay with Matt. Fantastic. So let's take a little spin on other side. So you probably have done lots of research about what adversaries are doing, with AI today and how they're using it. So our simulations, are they keeping up with that, what they are doing, or still poking, prompt injection, things like that?
Yeah, I think I've got some more hot take and maybe controversial opinion on this. And it's that, honestly, I don't think we're keeping up necessarily. We are in a lot of ways, but they're in a kind of different way than you would expect. I think oftentimes we look at, can we make the model say something bad? Or can we make it give away information that perhaps it shouldn't? But I think attackers are looking at what they can do in a more traditional sense. Can they have this credentials? Can they have access to, like write access to artifacts or systems that they shouldn't be allowed to have? And that's, like Rachel said, a very difficult thing to test. Like, how can you automate this process where you've got an unlimited attack space? You could provide whatever words you want into a model to try and make it achieve something. You can access the entire web as an attack vector. And also the kind of time it takes to carry out this testing is extremely long. It costs a lot of money and it takes a lot of time. So you can't test everything. So, sorry, that was a lot of talking. What was the question again?
It was, are we keeping up the simulations? And yeah.
Okay, so this kind of leaves us with the fact that there's so much to test. And an attacker just has to find one entry that allows them to do what they want. We have to defend from every single opportunity. And so, yeah, I would say, no, we're not keeping up. But like Vas said, if we apply enough security controls, we can raise the cost for the attacker such that it makes it very difficult for them to find these opportunities, even if we don't secure the entire thing.
So I also co-chaired the CTI layer for the Gen AI side. And so we've been tracking this and we did some research on this. And last year we kind of came up with like this really short phrase of like, if you have about 80% knowledge of what you're doing, you can get about a 20% uplift from AI, right? Like in a malicious way. Like a good example of this I always talked about, and this primarily applies to frontier models that have ethical guardrails and things like that, which we have seen in Anthropic's report that these are being weaponized, right? So I think that is significant change. But walking it through Kerber roasting, right? If I just went to like chat GPT and like, give me a Kerber roasting script. No, sorry. But if I'm like, can you enumerate all the service principal name, right? If I step it through, it'll get me there, right? But I had to already have like 80% knowledge of what Kerber roasting is to get it to give me that 20% uplift. Anecdotally, I would say that that's changed to about 85-15, right? Like there has been some pretty significant changes, but a lot of it that we're seeing has to do with the corpus of information that's available, which makes sense, right? A lot of the exploitations that we see that are happening AI driven are like web application vulnerabilities, right? Because they're very well documented. So I think there's actually an uneven distribution of the uplift that threat actors are getting. And it primarily, that uneven distribution of how much uplift that they're getting has to do with their own skill set, their targets, and their objectives, right? I think for the first time this year, we've had an APT group very publicly say, we used AI to like create all of this stuff because we have no idea what we're doing, right? And that was new. And like even a year prior to that, I was reporting on dark web chatter where essentially threat actors were making fun of each other for suggesting that you use AI for malware development. So I think there has been this really significant shift that we're seeing, but I don't think it is as catastrophic as it's often portrayed as. But I think it's incremental, and I don't know because there's so much doom and gloom that's like constant headlines, I worry we get fatigue in this area. And that as these significant changes happen, where we're seeing massive weaponization of frontier models, people don't realize the steps that are taking, because they're like, at this point, they're so inundated with the alarm bells, they don't notice the incremental changes.
Dan, you have something? Sure.
Yeah, I just wanted to add a bit more. I totally agree with those points, right? And especially around like increasing capabilities, right? Every time there's a new release, there are new capabilities, they need to be tested. You kind of have to wipe the slate clean and start again. And I think that instead of just sort of testing as we have done since like, I don't know, 2022 on fuzzing prompts and checking for particular behaviors and known exploits, what attackers are actually doing, particularly in the agentic world, is exploiting the system, right? And we've moved from prompting, like a model where you have a user puts a prompt in, you have inference, the output is maybe assessed as well, and you have a sort of firewall checking in that sense, right, of a live environment. But now we have an agentic setup. There's a prompt that goes to a planner, and maybe you have some memory calls, right? There's retrieval there, maybe some memory that's provided in the context. Then there are actions and like, I guess, tool calls that are kind of chosen, reasoned about, actions taken in an environment that we as humans are working in. And you can see it's getting bigger and bigger, right? And then once that environment changes, you need to go back to the planner and see if we're closer and closer to the prompt that the user wants us to achieve, right? And I think attackers are really exploiting that because there are many steps here. And within each of those steps is like a blind spot, right? So you can test those things on their own, the components like individually, but at some point there is going to be a miscommunication or a bridge that there's a blind spot that is ripe for the taking for an attack. And I think that there are interesting examples that give me hope of like rogue agents, red agents, running in environments, simulated environments that exist. But I don't think we're really there yet. So that's my small addition.
And that's excellent outline. Yeah, so it's like we're moving from the testing the model only, right, to more of a testing the system with multiple steps. So if we consider the system, and you outlined very well the process and components of it, and memory tools and so on, and agents, where do you see the biggest blind spot that we have today in those systems?
Yeah. So actually, great work that the agentic team did early on was talking about the dimensions of risk when it comes to agentic systems. And I love the kind of three breakdowns, because if you think of them as sliders, right? How much agency does it have? How much integration does it have? And this is where like that systematic testing and threat modeling is really important. And as you said, threat actors. Yeah. Threat actors are threat modeling the capabilities of your system. So I sure hope you are, right? Like, so right, the integration and then interaction, like how free is that interaction? Like, do your users just have like 4 drop downs, but you have a lot of integration and you have a lot of agency? Then, you know, that risk might be a little bit different than if it's like full free on text, right? Because then prompt injection starts to become a bigger issue. So I think, you know, when it comes to the blind spots, it's that when we have set up our AI governance, when we set up all these policies now that, you know, have been running, we didn't ask those questions to get those dimensionalities, because agentic really wasn't a thing when we first set up our AI governance. So a lot of organizations, myself included, are having to go back to our governance process and make sure we're asking those questions in a way that IT system owners can actually answer, right? In order to actually understand that, because those sliders are integral for not us just understanding risk, but actually for us understanding how much can red teaming, like adversarial input testing, actually help control that risk, right? Because there's agentic implementations that you have where your risk reduction from doing a red teaming exercise is fairly minor. And there's others where red teaming is absolutely critical for you understanding the security guardrails you need to implement.
just want to add to that. Yeah, so in terms of blind spots, right? Like I just mentioned, these you have all these components, and I think I have a very interesting example. A researcher from my team put together an experiment earlier this year. And what he did was he built like a mock-up of an email client. So you can send and receive emails, and then you can have the agent kind of summarize those emails, right? And as usual, you try to attack it by emailing in and having your context provided. But what happened was that he was able to poison the memory and actually break up a malicious prompt into many different small components and send them in over like 10 emails. And he did that with a key. So the language model had the capability to put together this malicious prompt using that key after it had tried to do retrieval and summarize the emails. Which I guess is also another interesting example back to the first question, right? But interesting finding. Yeah, and I think that the flaw here is, again, this sort of blind spots, right? You have these components that are handed over as there was once a sort of email checker scanning for, is there any malicious prompt here? No. So you pass it on. But when memory retrieves, it kind of assumes that that job's done, right? It's filtered. It doesn't realize that the model is going to be, pulling together all these prompts. And a really interesting fact about that is that it didn't matter what order you sent those emails in. So the model was still able to kind of put together and reason about what the prompt should be. So yeah, I think those are blind spots that, going back to this component example.
Matt?
I think I don't really have too much to add. There's a lot of blind spots in these models, and there's always going to be a way to take advantage of your system. But that's kind of part and parcel of building these things. We're not trying to build, 100% secure system. We're trying to understand if we can add enough value that it offsets this kind of almost like risk balance case against the cost that happens against a small chance of an incident. And that's a question that you kind of have to ask yourself. Is it worth building these systems? In many cases, yes. In some cases, no. I work a lot in kind of highly sensitive or like constrained environments, and we almost work the other way. So we don't build a capability and then try and add security in later. We come up with an idea and then find out how small of an area we can build it in. And if we can build it in that area, great. And if we can't, then it's just an unacceptable risk that we don't take. So it's one of those things. Yes, there's lots of different blind spots and they can hide anywhere. One of the probably most prominent, like you said, is where your system takes on untrusted data sources and uses them as part of the trusted system, like kind of prompt or system instructions. So this is almost kind of exactly what's happening here. Yeah, that's
How are we on time? Anyone who's watching time? And I was like, almost break time. Anyway, there is a question. So before we end the panel, let's see what was the question.
So how do we realize objectives in a agentic system rather than relying on isolated provenance attacks?
So I'll talk about a project that I'm aware of at Microsoft.
The question
Oh,
is
yes,
about
sorry.
simulation.
Yes, sorry.
Sorry, this simulation question of the attack simulation, right? And how do we repeat it, like make it repeatable?
Yeah.
Yeah.
Like realistic multi-step adversarial objective in agentic systems rather than relying on isolated prompt-based attacks.
Yeah, so how do we make it realistic simulation rather than relying on single prompt attack?
Yes, I think a big part of that is getting the environment correct. And so there's a project I'm aware of at Microsoft where we're trying to build essentially a mock-up of some SharePoint environment where you have all the like artificial files, you have like permissions on those, you have users, and you have a real sandbox that you can run an agent in. And then you can have a red agent that has some objectives that are malicious, and you want to try and steal some information from a file that you don't have access to. And so obviously then you can define multiple objectives for that. But I think the environment is one of the key points, right? You want to make sure that it's realistic, and then I think moving more towards an agent doing that for us, because it's going to be hard to do that, like, as you said, with single prompts, right? And then there's a big question in like, who owns that, right? Because if you're building a rogue agent or red agent, and it's sort of needs to be trained to do malicious things, and anything you have that's open source and public has been aligned, it's been kind of, removed from the bad behavior. And so to get the best testing, you kind of want something whose capabilities is malicious. And you don't really want to give that out to the public, right? Because then it can kind of hurt you later and you shoot yourself in the foot. So there's also a big question, I think, around like ownership of these rogue agents.
So I think threat modeling is super important. There's a fantastic guide around threat modeling for generated systems. And actually, once you have able to describe the threat model based off of the capabilities of the systems, right? Remember agency, integration, interaction. There's actually, when you are going through the prompting process, if you automate it with Burp or other things, you can actually use an AI agent to look at the responses that you're getting back from the system and judge, not on a pass fail, but if that's worth spending additional time on. And this is how we get scalability when we talk about using agents to do red teaming, right? Because it's non-deterministic, because we're dealing with context windows and prompt chaining, it's actually really important to realize, like you'll send a prompt and it'll be like, I'm sorry, I cannot answer that. Send the next, I'm sorry, I cannot answer that. I'm sorry. And then you're like, okay, well, what if I'm a developer? How can I help you? Now, it hasn't actually done anything malicious. You haven't gotten a finding, but that's, if you just kind of run it through like automated systems, like an automated system would be like, that was a fail. That's not a fail. That's a spend more time on that, right? And you can actually use agentic adjudication systems while you're running your burp test for these prompts and say, kind of tell me which one of these appears to be a successful nudging of a guardrail or getting me closer to a jailbreak. And that's the kind of like nuance that I think is really important, that doesn't maybe carry over very well from like traditional web application testing, because you do just kind of have pass fail states. But that's a really good way that you, especially if you inform that agentic system with what the threat model is, like what is the system actually intended to do? What is it hooked up to? Like, is it hooked up to my SAP in my system? The prompts it's going to send and what it's going to try to have for an objective will be vastly different for that versus like a help desk, chatbot. So
I have a couple more questions. We're gonna do fast.
I think the question would be.
One, okay, then very quickly, I'm gonna ask this both. Very quickly to summarize. So there's a very interesting trend that's going across the industry about continuous red teaming or automated red teaming. So what is your opinion on that? Are we there, or is just we talking only about this, or are we there? And then if you can summarize one thing that whoever is planning for red teaming should consider as part of their agentic AI system red teaming exercises. So let's start with Rachel.
I think we're closer than we were there a year ago when I looked a lot at these. Like, it's a lot closer. I think you still need some pretty significant expertise. Now, how many people on the team you need to have that expertise, I think, has been reduced. Tools have gotten us there. The one thing people really need to have a strong skill in for this area is threat modeling. Like, really understand how to threat model these systems.
Yeah, I think you're completely right, actually. So automated red teaming, yeah, I agree. We're not there. We're kind of moving towards that, but at the moment it's aspiration, I think. I guess one of the things I would say as well is like, what's the cost of continuous red teaming? Is it worth it? How much of your system do you actually have to test to be happy that it's secure enough? So I think automated red teaming, it's not really that. The things that I think are the most important, like maybe you said in some systems, red teaming didn't add that much value. I think things that do add value always are like improving the way that you monitor a system, and then how you remediate that system when it fails and how you improve it over time. So it might be that you do red teaming every now and then and you improve it from your findings. But it could be that you just sit down every time there's an incident and really understand how that happened and how you could improve your system going forward. And then what would I recommend people doing today is if you're building a system and you've got it working, yeah, don't just throw prompts at it. Like, who cares if it swears at you? Probably, but think about what actually matters. Like, what's the really important things, and where are the really bad fails in your system, and try and kind of protect against those.
Cool, yeah. I think I kind of alluded to it with the rogue agent and red agent that, I think that's the approach we need for sort of continuous red teaming of an agentic system. And also, I think we're not exactly there, but where we are is that, continuously log, right? Log your tool calls, log data provenance, try and keep as much track of as much information as possible, so that we can, review it and it's easier to kind of grow and learn. If I could recommend anything to people going out to red team their agentic systems, I think this year I really try and say this as much as I can. It's that AI red teams and the classical security red teams need to work together at the same time. Like, right, it's with all these components that are mishmashed together and the gaps in between, it's not enough to just pass a deployment to red team it from the classical security sense, say, okay, yeah, lock down the browser, lock down the VM, we're okay. Like, no, now we're protected against those threats. Move it to the AI red team, and then they check the model and the more subtle information flow. Well, I think information flow is key, right? So you can track the flow of information that goes from the system into the agent through the model. Once it's touched the model's been tainted with that information, good or bad, and then might go back into the system again, right? And I think having a 2-hour session between both your classical AI security red teaming and your AI red teaming, a 2-hour session with the architecture in front of you, blueprint, whatever it is you need, will work wonders, much more than kind of passing off to both teams in sequence.
Very fascinating. So threat modeling, what's important, telemetry, and the bonus one, working together, classical and AI red teaming. Awesome. Thank you so much for your wealth of knowledge and interesting answers. John, back to you.